working on 8BB, which is linear and nonlinear equations and graphs. Our content objective is students will be able to determine if an equation is linear or nonlinear. Our language objective is students will be able to explain why an equation can be described as linear or nonlinear. And why am I learning this? Well, it's important for graphing linear equations. So first things first, I just want to remind you, just by looking at a graph, we can tell if something is linear or nonlinear by saying if it's a straight line, like so, it is linear, and if it's not a straight line, like this example here, it is nonlinear. So here are some more examples. Again, if it's a straight line, it's linear, and if it's not a straight line, it is nonlinear. Now, the other thing I want you to recall from this slide is if the degree is 2, whoops, that was horrible. If the degree is 2, then it is going to be the shape of a parabola. And in this case, we would say, of course, it's nonlinear, it's not a straight line. So here, since the degree is 2, it's another parabola, so it's going to be nonlinear. Here, if the degree is 3, you're going to expect this shape, which we refer to as a cubic. That's not the official word, but in class, that's what you're going to hear us say. Again, here, since the degree is 2, since the degree is 3, it is going to be a cubic function, therefore it's nonlinear. Last but not least, here, since it's the absolute value of a variable, notice I'm being very specific, it has to be the absolute value of a variable, you'd expect the shape of the graph to be a V shape. Okay. So again, notice I didn't talk about the degree. I talked here. The main thing was the absolute value sign. If it's the absolute value of a variable, it will be a V shape. Therefore, you can say it is going to be nonlinear. The problem, hopefully you recall that it's in the form of y equals mx plus b. So all you need to really do is plot our y-intercept and then use the slope to graph some more points. So in this case, I can say it is linear. Why? Because this is a straight line. But something I also want to bring focus to is the fact that the degree of each variable is a 1. So think about that as we move down in our lesson. So in our next example here, you'll notice this one's also in the form of y equals mx plus b. Some of my students have stated that they found these to be difficult because why? They were trying to use a table, which nothing's wrong with using a table, but don't forget how to use slope-intercept form. So in this case, you could have simply plotted the y-intercept, which is 0, 3, and then used the slope of -4/3 to graph some more points. And here you can see that it's linear because it's a straight line. So once more, I want you to notice that the degree of each variable is a 1. Now, for those of you who are choosing to do a table for this, just recall that as you pick input values, you should probably use easy values. So maybe instead of -2, -1, 0, 1, 2, you might want to do multiples of the denominators. Hopefully you remember that. You might want to do -6, -3, 0, 3, and 6. This would make it so that you don't have to deal with any fractions. So hopefully that recalls some familiar things from past lessons. Same thing here. This was from a few lessons back. We did graph this briefly using slope-intercept form, but here the whole point is you'll notice this one's linear and that the degree of this one is also 1. So just keep that in mind as we go over the next few problems. So if you recall, linear equations is basically an equation whose graph is a straight line. So here's an example of one, here's another example, and here's another example. Now, examples of equations that are not linear will include the following. Y equals 3x squared plus 8, x squared minus 4y squared equals 12, and y equals 2x cubed minus 5. I'd ask yourself, what is the difference between these equations? What's so special about these in comparison to these problems? Well, hopefully you're able to see that here the degrees of the variables is some numbers other than 1. Okay, the only way an equation can be linear is if all the degrees of the variables are 1. So notice all of these are 1, but some of these are other numbers other than 1, therefore making it nonlinear. So here, you know that linear equations have variables that are all to the first power, so that's made very clear. So how can you tell if something is nonlinear? Well, you know if something is nonlinear if you have a product of a variable. So let's write down an example of what that might look like. So x times y equals 3 would be nonlinear because those are product of variables. What else? If you have variables as exponents, so here, since x is an exponent, this would be nonlinear. And last but not least, if the variable is in the denominator. So here, y equals 6 over x. Since x is a denominator, it is nonlinear. So now let's take a look at some examples of equations and let's determine whether or not it's linear or nonlinear. So here it says determine whether the equation is linear or nonlinear. Number 1, y equals 3x plus 4. I would say this one is linear. Why? Because the degree of each variable is 1. Now what about number 2, x times y equals 7? This one would be nonlinear because this is product of variables, like in our notes from the previous slide. If it's a product of variables, it is nonlinear. Here, what do you think? Is it linear or nonlinear? Hopefully your response was nonlinear. Why? Because in the previous slide it also said it is linear if the degree is 1. Here, the degree is not 1, therefore it is nonlinear. Here, I would say this one is nonlinear. Why? Because the degree of each variable is 1. And last but not least, what about number 5? Once more, this one is nonlinear. Why? Because the degree of every variable isn't 1. So that is nonlinear. Number 6 is a very tricky one. So first we need to recall normally what would the shape of an absolute value be? We would think it's the shape of a V. So some of you may say, oh, it's nonlinear. However, if you remember from that background knowledge slide, I did mention it's the shape of a V if you're taking the absolute value of a variable. This is not a variable. You're taking the absolute value of a number. In fact, you can think of this as y equals 3, because the absolute value of -3 is 3, so this is actually linear because the degree of each variable is 1. What about this one? This one is nonlinear because the variable's in the denominator. What about this one? It is nonlinear because the degree isn't 1. Number 9, it is linear because the degree is 1. And last but not least, this one's linear because the degree is 1. Next, number 11, this is nonlinear because the variable's in the denominator. Number 12, this is nonlinear because the degree is something other than 1. Number 13, this one's actually nonlinear because you are taking the absolute value of a variable. And we know when you're taking the absolute value of a number, when you graph it, you end up with a V shape. And we know that is definitely not linear. Number 14 is nonlinear. Why? Because you have product of variables. And number 15, it is nonlinear because your variable is an exponent. So now we're going to practice graphing some horizontal and vertical lines. So here it says graph y equals 3. Notice this is a simple rule. They're telling you y has to equal 3. So I'm going to go ahead and create a table for myself where I'm going to follow instructions. It says y equals 3. So what I'm going to do, I'm going to put 3 for all the y's. Now I'm just going to pick some numbers. I'm going to go ahead and pick -3 all the way to +3. Now that I have those points, I can go ahead and graph them. Notice here, this will create a horizontal line. And that's it. So you're going to notice all lines in the form of y equals a number will be horizontal. Okay, well what about if it's x equals a number? Well, same idea. This is the rule. It says x equals -2. So I'm going to go ahead and create a table where all the x's this time equals -2. And I'm just going to pick some values for y. In this case, I'm going to go from -3 to 3. Now that I have ordered pairs, I'm going to plot them on my graph and draw my line. So here, x equals -2. So you're going to notice all lines in the form of x equals a number will be vertical. Okay, so now what I want you to do is go ahead and pause the video and try this one on your own. Okay, so we're back. Hopefully you went ahead and first started a table and said, okay, well, since y equals 0, let's put a bunch of zeros in the y column. Now for x, I'm going to go ahead and pick any numbers. In this case, I'm going from -3 to 3. I'm going to go ahead and plot my point, and there you go. You have a horizontal line right on top of the x-axis. So here I would say this one's definitely linear because it's a straight line. Okay, so now what about this one? X equals 3. Again, create a table where all the x's are 3s. And then for y, you can put any number you want. I prefer you to go from -3 to 3, but is it wrong to pick any other points? Definitely not. Here, you're going to plot your points, and you'll notice it is a vertical line. Okay, so this one's definitely linear. Now, let's try this one. Go ahead and pause the video and see what you get. Okay, so we're back. So first things first, you're going to go ahead and create a table. Here, the graph says, here it tells you to graph y equals -2. So for the y's, I'm going to go ahead and put -2 since that's the rule, y equals -2. Now I'm going to pick any value for x. I'm going to go from -3 to 3. I'm going to go ahead and plot my points and notice I have a horizontal line. For our next problem, it says x equals 4. I want you to go ahead and pause the video and try this one on your own and see how well you do. Okay, so we're back. So first things first, it says x equals 4. So what I'm going to do is go ahead and create a graph where all the x's are 4s, since that's the rule, x equals 4. Now I'm going to go ahead and pick any value for y. I do prefer you to, in this case, choose -3 to 3. And then you simply plot the points. Just a friendly reminder, this would be 4, -3, 4, -2, 4, -1, 4, 0, 4, 1, 4, 2, 4, 3. And you'll see that you have a vertical line. So this one's obviously linear. So now, last but not least, go ahead and try to graph x equals -3. Okay, so we're back here. I'm going to go ahead and create a table where all the x's equals -3, since that's the function rule, where x is equals -3. Now I'm going to go ahead and pick some negative and positive values for y. In this case, I'm going to go from -3 to +3. Go ahead and simply plot your points, and you'll notice we have a vertical line here. So if all else fails, always revert back to creating a table. And that's going to conclude the lesson for today. And almost forgot to mention, this one's definitely linear since it is a straight line. And like always, thank you so much for tuning in. And until next time, bye.